Jai Hind. Today the topic which I am going to discuss with you is mobile agents, and this comes under Unit 4 of the subject Mobile Computing with the code KCA 051. The contents which I am going to discuss today, basically introduction of the mobile agents, then what are the other paradigms available other than mobile agents in mobile code subsystem, then mobile agent applications, characteristics of mobile agents, benefits, and the last one is references. So basically when we say mobile agent, it is a distributed computing paradigm and it has become viable with recent technologies. For example, we are having Java and other languages available which are supporting the distributed computing environment. And mobile agents, basically they are being deployed for the network applications, although they had not been widely used. So when we talk about the mobile code system, then we are having 4 types of mobile code system. One is the client server architecture, another one is code on demand, third one is your remote evaluation, and the last one is mobile agents. Now on what basis we are categorizing these 4 basic types? These have been categorized on the basis of 3 basic elements, that is data, code, and program stack. Data says that where we are storing the results, and these results, they can be the final result or the results which are being generated during the any computation, that is your intermediary results. Then we are having code, that is a set of commands which are being executed, and program stack. Program stack, that it shows the current status of any program, that at a particular instant what are the elements within a program, at which PC value the program is being executed, what files and other resources this program is currently being used. So it this has been characterized with the help of program stack. So whenever we are having a program running in any environment, whether it is a distributed environment or a centralized environment, then we are having 3 elements, data, code, and program stack. How these 3 elements being distributed throughout the system, it results in 4 types: client server, code on demand, remote evaluation, and mobile agents. So in this figure, what we are having, the first one is the client server architecture. Now what this client server architecture, it shows, it says we are having some data available with our system, computer A, that is, this is, you can say, this is our host system, and we want some computation to be done on this data. So what we are doing, we are sending some request to the computer B that we want such and such particular execution done on the particular data. Then in this case on the computer B, that is, in this case it is our server, the data, it will move to the server side, and on the server we are having code, and this is the local data which is available at the server. So along with this data, code, and its own local data, the server will do the computation and it will send the result back to computer A. Now the next category is the remote evaluation. Remote evaluation, it says that on the host we are not having the data. What we are having? We are having the code. Now we are sending these set of instructions to another system, and this data is local to this system. There, on the computer B, when the code reaches to the computer B, it will run or do the computation on that particular local data. In the case of the code on demand, what is happening? We are having both. We are having only data available with us, but now we are not moving the data to the computer B. What we are doing? We are computer B, we are requesting some code to the computer B, and the computer B in response is sending that particular set of instructions. When the computer A, it receives those instructions, it will run those instructions on the set of the data. Whereas in the case of the mobile agent, what is happening, both data and code, it is in the transition or movement over the network. Now what is happening in this case? In this case, the data and code, it both being transferred to computer B along with the local data available at computer B. Some computation is being done. And this movement is system to system, because here what is happening, it is sending the result back to the computer A. But in this case, if this computation can't be done on computer B and some another system, computer C, is required, then what will happen, this data and code, that is after whatever be the intermediary results being generated, that those results along with the code, they will be transferred to the system C. Then same thing would be transferred to another system D, and once all the computation got finished, the mobile agent send the result back to computer A. So what we have seen in client server architecture, in the client we are having the code. Now this code is being executed. It will call the procedure which is available at the server side. It will do the computation, return the result to the client, and the client will continue with its execution, with its operation. Examples, it may be your web pages, it may be your RPCs, web services, core bar, EJBs, and so on. In the case of the code on demand, what is happening? The client, we are having the code. It is sending the request to the server, to the service. The code is being transmitted, it is sending request to the server. Now the server is having the code and it will transfer the code to the client machine. It will execute the code and it will get the result. For example, your Java applets, they fall under the category of code on demand evaluation. Remote evaluation, in the case of the remote evaluation, the client is having the code, it will execute the code and then it will transfer the code to the service side. Here we got the code on the server machine, it will execute the code, it will return the result. Now the client will get the result and it will continue with its execution. For example, your SQL queries, they may come under the category of remote evaluation. In the case of mobile agents, what is happening? The client will initialize the code and it will transfer the code, because once it is initializing, that is, it is including the data in the code. It is being transferred to another server. Here, the server will execute the code. It will get some intermediary result. It will transfer the code along with those intermediary result to another server. It will execute the code and it will transfer the result back to the client side. So, in the case of the mobile agents, we have seen that data is semi-mobile in nature. That is, only those data is under the movement which is required for further calculation. That is your intermediary results. Code is purely mobile in nature and the program stack is also mobile in nature. So, agent, we can say that agent is an independent software program which runs on behalf of a network user. Agent may run when the user is disconnected from the network. That is, what is the biggest advantage of the agent? They are running on the behalf of the user, and if the user got disconnected with the network, agents still continue with their operation. In the case of mobile agent, what is happening? Now that definition of the agent which we have seen earlier, we are including the mobility in it. So a mobile agent, it is a program that once it is launched by the user can travel from node to node autonomously. That is, no interaction with the user in the later stages. only the user will initialize the mobile agent, and later on all the decision, all that is from which system to system the mobile agent need to propagate, all such kind of decisions is being taken by the mobile agent itself, and it can continue to function even if the user is disconnected from the network. There is another definition for the mobile agent, that is a mobile agent. It is a software program and data which represents a user in a computer network and is capable of migrating autonomously from node to node in a heterogeneous environment. That is, network need not to be the same, to perform some computation on the behalf of the user continuously with the features of, what are the features? It is autonomous in nature, it has the social ability, it has a learning ability, it is adaptive to the network or the environment on which it is moving to, then reactivity, mobility, etc. They are defined as objects that have behavior, state and location. That is, we can say that is a mobile agent is an object that can have a behavior of its own, a state of its own, and as well as it is aware of the location. So in this diagram we are having the user, once it is being a mobile agent being initiated by the user, it can travel from one server to another server, and then it may go, the final result may reach to the user. So what we are having, we are, for instance, here we are having a database server, agent server is there, then it is moving to this, it is being handled by the agent server which is residing on the file server. So a mobile agent, it performs the work on behalf of a user as it travels to multiple locations on the network. Now, what's the difference between the client server and the mobile agent? In the traditional system, we are having a client. It is sending some request to the server. Server is performing the calculations or providing the services back to the client, or we could say it is responding back to the client with the services which the client wants from the server. Whereas in the mobile agents, what is happening? The client is sending the agent to the server. Now these servers, these agents, they are being moving from one server to another server, and once the agent does the final computation, it will return back to the client. What are the various areas where mobile agents can be deployed? One of the most significant application is the electronic commerce. Many commercial transactions, they require access to resources in real time. Therefore, the ability of the mobile agent to personify their creator intentions and to act and negotiate on behalf of them makes it well suited for the electronic commerce. That is, it can do the bargaining on the behalf of the user. It can act as a personal assistant. How? An agent can act as a personal assistant to the user and perform task for user on a remote host, regardless of whether or not the user is connected to the network. For instance, to schedule a meeting, the user can run or dispatch a mobile agent onto the network to interact with the agents which are belonging to other users. Now these agents, they can negotiate it among themselves so that they can come upon a specific date, time and venue to schedule a meeting. Another important application is your secure brokering. A mobile agent is an attractive solution to brokering, particularly in context of untrustworthy collaborator. That is, if there is no trust among the collaborators, but still we want to negotiate on certain aspect, then in that case, the interested parties can let the agents meet and negotiate at a mutually agreed, impartial, secure host, and they can form the alliance. Distributed information retrieval. Here the mobile agent technology provides efficient information retrieval when dealing with large amount of data. Rather than moving all the data to the search engine to create the search indexes, user can simply dispatch the agents to remote resources to create those indexes locally and to search them back later to its origin. Telecommunication network services, it provide an effective and flexible solution to the management of advanced telecommunication services by providing dynamic network reconfiguration and user customization. Workflow applications and groupware, here the mobile agents, because of their features of autonomous and mobility, it provides autonomy to the workflow item and support the information between the co-workers. Flow of information between co-workers. Parallel processing, if a computation requires large number of processing power, then in that case, we can distribute it to multiple processors with the help of mobile agents. Monitoring and notification applications, as a local representative for remote services, an agent can perform tasks on behalf of a user, irrespective of whether or not the user is connected to the network. For example, a user can dispatch a mobile agent to the internet to monitor the stock prices and to notify whenever there is a certain threshold which have been set by the user, by the creator of that mobile agent reached. Information dissemination. Mobile agents exemplify the internet push model and can distribute information such as news, softwares, updates for the vendors. The agents, they carry the upgrades and installation procedures directly to the user's personal computer, and without any user intervention, they can update and manage the software on the computer on the behalf of the user. So what are the basic characteristics of the mobile agent? So we should have a mobility of code and data from one host computer to another. It should have ability to learn in order to adapt the code and data to host computing system, that it should be able to work in a heterogeneous environment. So it should be adaptable to various environments. Ability to continuously and autonomously process the request and send the data. How we characterize the mobility? Now we are having three capabilities. When we talk about we have seen three capabilities of a mobile agent. One is code, another one is computation, and then the state. So when we are saying the mobility, we need mobility with respect to code, with respect to computation, and with respect to state. So various combinations are possible on this. So in this diagram, if we say on the x-axis we are having mobile code which require the remote installation. Here we are having the mobile computation. Here we go for RPC, servlets, stored procedures, and when we want the mobility with respect to state, then we can achieve this with the help of check pointing. Mobile code, it says it allows the executable code to be moved to a new host, and it may use both the models, push or pull model. When we talk about the pull model, then applets, they can work. But when we talk about the push model, then we require the remote installation in that case. So mobile agents, they use basically push. Most of them, they work on the push model. Sometimes an agent push may result in a code pulling of the code. Now code may be binary, it may be intermediate or native source code. What are the advantages when we are having the mobility with respect to code? Dynamically change the capabilities, download new code to add, change or update the capabilities of the platform, remove the code when no longer required. But what are the problems? Security concerns due to untrusted and unchecked code. So the code could be malicious, buggy, or it could be a tampered one which can you could say attack a machine. When we talk about the mobile computation, then here evolution of remote computation is being done with the help of RPC, RSH, remote shell, remote MI, servlets, stored procedures, core bytes, etc. Allow one system to run a computation on another system, and it utilizes resources on remote system. These resources, they could be CPU, they could be memory. It could access the resource on the remote system, which can be files, database, etc. When we say mobile state, evolution of state capture, it can be done with the help of the checkpointing. It allows the execution state of a process to be captured and moved. The state may be machine specific or machine independent, may contain a state of a single or a multiple threads and a code. So what are the advantages of mobile agents? The very first advantage is the reduction of network traffic. In distributed system, performing a simple job involves multiple interactions, resulting in increased network traffic. In mobile agent paradigm, the objective is to move the computation to the data rather than the data to the computation, thus consuming fewer network resources and thus increasing the efficiency of the bandwidth, Overcome network latency. And how this particular thing has been achieved with mobile agents? Management of critical real-time systems with substantial size. Network create latencies which are unacceptable in the real-time applications. So the deployment of mobile agents will overcome this problem, since these agents can execute locally upon the central controller's directions. Encapsulation of protocols. Often as new communication protocols which improve efficiency and security emerge, business need to upgrade their protocols. Otherwise, they turn into a legacy problem. This whole process is cumbersome. Mobile agents will resolve this issue as they can migrate to a remote host and establish channels based on proprietary protocols, asynchronous and autonomous execution for jobs that require a continuous open connection. Deployment of mobile agents will result in cost saving. Mobile agents with the embedded task can be dispatched into the network where they operate independently and asynchronously. Dynamic adoption. Mobile agents, they can perceive the surrounding environment, and according to the environment, they can act dynamically. Seamless system integration, both from the perspectives of hardware and software. Networking, computing are heterogeneous. Mobile agents, they can provide seamless system integration since they are dependent only on those environments in which they execute. Robust, and they are fault tolerant since mobile agents, they can act and react dynamically in presence of unfavorable conditions. It is easy to build a robust and fault tolerant distributed system with mobile agents. So in the case of a heterogeneous mobile agent system, it is showing the architecture of a heterogeneous mobile agent system. We are having the agent servers and the mobile agent, they are moving from one agent server to the another agent server. Now the clients, they can be a thick client or they can be a thin client. As for example, this is a thick client, this is thick agent client, again this is a thick agent client, and it is a thin agent client. Here at the agent server, we are having mobile agents and the agent states. Now these agent states or the mobile agents, they can communicate with the thick client and the thin client. In the case of the thick client, since we are having a full-fledged set of the resources available with us, no constraint on the resources, so we are having the mobile agent, whereas in the case of the thin agent client, we are having the agent state. So thick agent client is able to execute mobile agents locally, while the thin agent client only able to manipulate the agent data, that is state. That is why we are having agent states in the case of the thin agent client. So here what we are having thick agent client. Here we are having the agent initiator. This is a general agent server services, agent regulations, location services, agent lifetime services, agent execution, all being done here. Here we are having the agent information available here in the database and other client capabilities available with us. This is the thick agent client environment, and this is a thin agent client environment. Here we are having the agent joiner or the splitter in case of the thin agent, and it is the mobile agent dispatcher. So what these components they mean? Agent joiner or the splitter. It makes it possible to split the data and code of the mobile agents before dispatching the agent to the thin client. As we have seen here, that in the case of the thin client, we are having agent state, whereas thick agents, the mobile agents, they can move and they can do the computation. So in the case of the thin client architecture, agent client, what we need a agent joiner or splitter and the agent initiator. The agent initiator is responsible for initiating the agent client first time or reconfiguring the agent client based on the changes in the mobile agent software or hardware software changes in the client. Mobile agent dispatcher, it makes it possible to dispatch the agents between client and server. So in this here we are having the agent initiator. Similarly, we are having the agent initiator in the case of the thin client also, but we are having additional component here, that is your agent joiner or the splitter, and this mobile agent dispatcher, it is responsible for both the environments, thick agent client as well as thin agent client environment. So these are the references which I used for this particular lecture. So what we have learned in this lecture, what is a mobile agent, what are the different paradigms, that is a client server, remote evaluation, code on demand, and the mobile agent environment. These are the various paradigms available in the distributed computing environment. And the mobile agent, it is the most desired, you could say, environment in the for the computation in the distributed computing environment. We have seen various applications where we could use the mobile agents. How the mobile agent being, what is the architecture of the mobile agent in the case of a thick client or a thin client? What are the various benefits of the mobile agent? So this is all we talked during this lecture. Thank you and Jai.